Here we're going to graph linear inequalities. Now, we already know about some inequalities like x is less than 2. And when we thought about this, we graphed it on a number line. And what we want to look at what we did with the simpler equation. So then when the inequalities get more complicated, we're going to do some things that are analogous. So first thing we did was find out where 2 was. And then we asked ourselves, could our solution equal 2? And in this case it can't, because it's got to be strictly less than 2. So the way that we signified that was with a circle. Then we drew an arrow that basically shaded the number line to the side, which included all of our solutions. So we tested a side, like over here we'd test 0, and over here we'd test 4. And if we plug 0 in there, 0 less than 2? Yes, it is less than 2. So we drew an arrow, or we shaded to the right hand side. And we could test 4, and you plug 4 in there. Is 4 less than 2? No, it's not. So we don't have any solutions on that side of 2. Our solution had to be a graph, because there's going to be infinitely many solutions. It's not just going to be one number that will give us a solution to this inequality. It'll be infinitely many of them. And we just wanted to kind of visually show where all those solutions are. Now let's look at y is greater than or equal to 2x plus 1. And this is something that we can't graph on a number line anymore because it is a line. And if we were to look at y equals 2x plus 1, that has a y-intercept at 1 and a slope of 2. So we go up 2 and over 1 for our next point, and that's where our line is. There we go. There we have our line. But this is an inequality. We have infinitely many solutions, and it's not just going to be everything that's on the line. Everything that's on the line is when y is equal to 2x plus 1. But what about all them times where y is greater than 2x plus 1? So what we should do is test a couple points. So I'm going to test a point that's some points that are definitely not on the line, like this point at 2, 1. And all we have to do is plug it in. Is y coordinate greater than or equal to 2 times the x coordinate plus 1? Well, is 1 greater than or equal to 4 plus 1? No. So that is definitely not a solution. On the other hand, what if I pick something on the other side, like right here? This is a point negative 2, 3. So we plug that in. There's my y coordinate greater than or equal to 2 times the x coordinate plus 1 is 3 greater than or equal to negative 4 plus 1 is 3 greater than or equal to negative 3. Well, yeah, every positive number is greater than a negative number. So this is a solution. Well, there's one solution. Other solutions are all going to be these points that are all on this side of our red line. So, and even the ones that are down in this quadrant too. Actually, everything that goes right up to the line is going to be a solution. So what we do is we shade this half of our axes. Everything right up to the line is going to be a solution, whereas everything on the other side of the line is not a solution. So if we're going to graph y is less than negative 1/2 x plus 3, we graph the line y equals negative 1/2 x plus 3. Well, this thing has a y-intercept of 3, so put a point at 3, and it has a slope of negative 1/2, so we go down 1 over 2, and this is where our line's going to be. But we have a problem. Remember, every point that's on this line is going to be a solution for when they're equal to each other. Like this point right here, that's the point 2, 2. And if we plug it into our equation, we'll have 2 is equal to, or excuse me, less than negative 1/2 times 2 plus 3. So 2 is less than negative 1 plus 3. 2 is less than 2. Is that true? No, it's not true. So when we graph an inequality that isn't equal to it, we can't have a solid line here. Just like before when we had x as being less than 2 and we tried to do it on a number line, we had to use a circle because we can go right up to that 2, but we couldn't include it. And we have the same idea here, that we can go right up next to this line, but we can't include it. So graphically how we signify that is, instead of using a solid line here, we just use a dotted line. So we would graph our line just like that, as a dotted line that follows what we need it to follow. Now we test a point. I'll test the easiest point there is and see if it works. Is 0 less than negative 1/2 times 0 plus 3? Is 0 less than 0 plus 3? Yes, it is. That means that all of our solutions are going to be everything that's on this half of the line. Let's try another one. X plus 3y is less than 9. Now this equation isn't in slope-intercept form, so I can't really look for intercepts and all that, but it's in standard form. So maybe we look for the x and the y-intercept. If we plug 0 in for x, we'll have 0 plus 3y is equal to 9. That means that y equals 3. And if we plug 0 in for y, then x plus 3 times 0 is equal to 9. That means x equals 9. So I'm going to need a bigger coordinate system, and we just plot these two ordered pairs. We have 0, 3, so over 0, up 3, and 9, 0. So we go over 3, 6, 9, and up 0. And here's our line. Now, should this line be a solid line or a dotted line? Look at the inequality. This inequality is strictly less than. It can't equal our line, so we just use a dotted line and then determine where we should shade. So how should we know where we shade? Pick a point and test it. I'm going to pick the easiest point, 0, 0. Is 0 plus 3 times 0 less than 9? Well, is 0 less than 9? Yes, it is. And so we're going to shade on this side of the line. Last one, let's graph x is greater than or equal to negative 1. Now remember, if we have y equals a number or x equals a number, it's either going to be a vertical or horizontal line. So here we find out where x is equal to negative 1. That's right here. And it's not going to be in the x direction. It's going to be perpendicular to the x-axis. So it's going to be vertical. Notice that every point on this line has an x-coordinate of negative 1. So that's how we know we're doing it right. Should it be a solid line or should it be a dotted line? Well, this is greater than or equal to. Since it's or equal to, it can be a solid line. And the last thing we need to do is to test a point. So I'm going to test the easiest point, 0, 0. Is 0 greater than or equal to negative 1? Yes, it is. So we shade that side. And that's how we graph inequalities. Graph the line, determine if it's going to be a solid or dotted line, then test the point and shade the side that contains the solution.